46, 55, 50, 68, 5, 87, 82. After class, let me look at your notes and stuff. All right. Now, that's it for the first section. Now, the second section is going to go pretty super fast.
More probability.
Yeah. But it's not probability like we've been doing it, sort of. Discrete and random are what we talked about before. Discrete is when you're talking about like hat sizes, dress sizes. It's when it can be certain numbers. Like you can wear an 8, or you can wear a 10, or you can wear a 12, or you can wear a 7.5, or you can wear an 8, you can wear an 8.5. You can't wear a 7.239 shoe size. Remember we did discrete and continuous? Continuous is when it can be any number. That's the same as what we were doing before. A random variable must be a number. It's got to be quantitative. No letters, no words. All right. Now, let me show you. Now, a probability distribution, and these are actually easier than what it looks like. A probability distribution, like I said, it has to be numerical. That means it has to have numbers, no words. Now, probability. We've been doing probability forever. Probability means it must, this one is saying it must add up to 1. If you're a boy and you're a girl, you all have to add up to 1 or 100%. The blues plus the reds plus the greens in the box have to add up to 1 or 100%. Y'all with me? The last one says the probability cannot be over 100. I can't say the probability of you passing this test is 140%. The probability has to be between 0 and 1 or 0 and 100%. So the probability must be between 0 and 1 or 0 and 100%. You can't have a negative probability. You can't have a probability that's over 100%. It's got to be between 0 and 1 or between 0 and 100. So this one says construct a probability distribution, and like I said, it's a whole lot easier than what it looks like. So if I was doing a probability distribution, I would have the number of TVs, which would be 0 TVs, 1 TV, 2 TVs, 3 TVs. So 26 people had 0 TVs in the house. So I want to know what is the probability of getting. Well, what does probability mean? Happy over total. So how many people had 0 TVs? 26. I just got to figure out how many total people there were. So if I add all of these up, the total is 2,600. So 2,600 people, so I'm doing happy over total. Draw a little line. So what would I do for 1 TV? 442 over 2,600. What would I do for 2 TVs? 728 over 2,600. What would I do for 3 TVs? There we go. And remember, we can do a fraction, we can do a decimal, we can do a percent. If it's a fraction, it has to be reduced. The decimal is going to be 0.01, 0.17, 0.28, and 0.54. Now, in order, this is called a probability distribution. That's it. You got to have numbers. I can't have red, blue, green. I got to have numbers. The probabilities have to be between 0 and 1, and these have to add up to 1. Now, they may be a little off from 1 if I do rounding. They may be 0.99, or they may be 0.98, or they may be 1.01, but they're going to be 1 around. So that makes a probability distribution. So if I give you some and I say, okay, like for this one, what is the missing probability in the probability distribution? So how do I figure out what this is? they have to add up to 1. So to get my answer, I would add them all up, 0.06, 0.12, 0.18, oops, and 0.30. I would add them all up, and then what would I do? 1 minus 0.66. So my missing probability is going to be 0.34. Because in order to be a probability distribution, they have to all add up to be 1. Cool? Add them all up and take it away from 1, because all of those little cents have to add up to $1. Or if you wanted to, this is 6%, this is 12%, this is 18%, this is 30%. They have to add up to 100%. If you're more comfortable with whole, like percentages. Now, this time I gave you tables and I want to know, are they probability distributions? So, number 1, are the categories numbers? Number 2, are the probabilities between 0 and 1? And number 3, do the probabilities add up to 1? Those are our questions. If all 3 of those are yes, then it's a probability distribution. So, if I look at this first one, slide over a little bit. If I look at this first one, are all of these numbers?
Yes.
Okay. Are all of these between 0 and 1? So now I just have to see if all of these add up to 1. 0.358, 0.439, 0.179, 0.024. Is that a probability distribution? Yes. Because all 3 of those things worked. Okay. Is this one a probability distribution? Are all of these numbers? Are all of these between 0 and 1? All those between 0 and 1?
Yeah.
Yes. So now I need to add those up. 0.493, 0.250, 0.127, 0.064. Is that a probability distribution?
No.
No. So this one is not a probability distribution. Now, if it was 0.99, really, really close, then yes. Is this a probability distribution?
No.
This is not a probability distribution because these are not numbers. You have to have numerical categories in order to be a probability distribution. Okay, these are numbers. These are between 0 and 1. So when I go to add them up, 0.659, 0.287, 0.050, 0.004, 0.001, and 0. Is this a probability distribution? I don't know. I think yes, because rounding caused it to be a little bit off. So I would say yes, that is a probability distribution.
And my math lab will say yes?
Yes. So, y'all, we have 9 pages left. We did 9 pages today. So we are looking at possibility of finishing Tuesday. If not Tuesday, we will finish the first part of Thursday.
And we don't have a test for this one?
We do have a test for this one.
Okay, good.
We have a test for this
I'd
one.
rather have a test.
And then we have a
I know
final
I can do
exam.
it before the exam.
Yeah, we have a test for this one, and then we'll have a couple baby sections we won't have a test for, and then we'll have a final exam. So you'll have 2 more tests. And y'all, your final exam counts just like a test. It's just on everything.
I'd rather have a small test before though, because
Yeah.
I can see
Little baby test.
what I can do with that.
Will you, let me lock the duties so the computers are locked so you can push it down. Will you